Good morning, students. Today we are familiar with shift register counters. As we know, registers are used for storage, but with name as counter, basically it is storage and transfer of digital data in a particular sequence. So it is called shift register counter. The basic difference between a shift register and the counter is that a shift register has no specified sequence of states except in certain very specified application, whereas a counter has a specified sequence of states. If the serial output of the shift register is feedback to the serial input, we do get a circuit. It is called shift register counters in particular sequence. Depending upon the nature of feedback, we have two types of shift register counters. First one is ring counter and second one is Johnson counter. Johnson counter is known as also twisted ring counter because the pattern of feedback. First we read about the ring counter. Ring counter or ring shift register. It is simplest shift register counter. It is used n bits, then it is used n flip-flops. In this example, we are designing 4-bit ring counter, so we take 4 flip-flops because it include n states with n flip-flop. Okay, this is the flip-flop 0, 1, 2 and 3. It is synchronous counter, so this is the negative triggering clock pulse is given at the same time of the all flip-flop. This is ring counter. Here we take the D flip-flop. What is the function of D flip-flop? D flip-flop is given output as the input. It is pulling the input to the output in the same manner. So D0 is passed the output to Q0 and Q0 is connected to input of next flip-flop and its output Q1 is connected to next flip-flop input. And finally this is output of this flip-flop is connected to the input of last flip-flop and the output of last flip-flop is feedback to the input of first flip-flop, that is D0. It is designed a ring, so it is called ring counter. The main difference between the ring counter and Johnson counter is feedback output. This is the normal output and it is the inverted output. So we feedback the normal output to the first flip-flop of this counter. So it is called ring counter. Okay. For bit ring counter using the D flip-flop, all flip-flops are connected in the normal shift register, that is Q output of each stage is connected to next input, but output of last flip-flop is connected to back of the D input for first flip-flop, such that the array of flip-flop is arranged in a ring is named as ring counter. Okay, let's start. Assume flip-flop 0 is set to 1 and all other flip-flop are reset, that is their output is 0 0 0. Okay, in this case the counter output is 1 0 0 0 before apply the clock pulse. This is the output of all the flip-flops 1 0 0 0. Okay, what happened with when we apply the first clock pulse? When we apply the first clock pulse, the 1, this is the output of Q4, this is the M0, Q0, Q1, Q2 and Q3. Q3 is shifted towards the Q2 with the first clock pulse, and then second clock pulse is shifted to Q1 and the third clock pulse is shifted to Q0 and the fourth one it is repeat itself, that is 1 0 0. See here in the diagram, this is 1 0 0 0. Initially we set first clock pulse, the output is 1, this is 0 0 and 0. After apply the first clock pulse, this 0 is feedback to the first clock pulse, and this is D flip-flop, so it is pulling the input as the output. So 0 is getting the output as Q0, and this the 1 is shifted to Q1, and this is 0 to 0. So it is a shifting process of the D input as well as output data. So we get the output at repeat itself after the 4 clock pulse. So we can say its frequency of each state is frequency, total frequency f is divided by n. N is number of states or number of bits, that is the 4 bit. So f total frequency upon n, that is the number of states. This is the our transition diagram, that is the first 1 0 0 0, that is the first condition. After first clock pulse, second clock pulse and third clock pulse, and after third clock pulse we get the previous condition. Here the clock pulses, when 0 clock pulse we have the state of Q0, Q1, Q2 or Q3 is like this. This is set and all other flip-flops are reset. After the first clock pulse, this Q3 is feedback to Q1, Q0. So it here the 0, and this one is shifted to next one. This 0 is shifted to this, and this 0 is shifted to this. After second clock pulse, this 0 is feedback to Q1. So this is here 0. This 0 to 0 shift, this 1 is shifted here, and this 0 is shifted here. After the second clock pulse, we apply the third clock pulse. In third clock pulse, this 0 is feedback to Q0. So again here 0, this 0 is shifted to here, this 0 is shifted to here, and this 1 is shifted to here. After third clock pulse, we again apply to fourth clock pulse. This 1 is feedback to the Q0. So 1 is here, and this 0 is feedback to this transfer, because it is the shift register, just transfer the data. So this 0 to 0, 0 here, and this 0 is 0. See here, this is our previous or first condition of the all flip-flop before the applied the clock pulse. So it is repeat itself after the 1 2 3 and 4 clock pulse. This is the 4 bit, so we require the 4 flip-flop, and the state is 4. It is n, so it is frequency is each state frequency is total frequency divided by n. Okay, after that if we again apply the frequency 5 6 7 and 8, it is repeat itself. So we can say the number of distant state in the ring counter, that is the mode of ring counter, is equal to number of flip-flop used in the counter, and its frequency is equal to total frequency divided by n, where is n is the number of bits used in the counter. It is the number of bits always equal to a number of flip-flop. The big difference between the counters and this counter, this is the ring counter, is that if we have in the synchronous counter or counters we have n bits, then we have to keep our n states. Example, for if we have n equal to 4, that we have to keep our n, that is 16, means it counts 0 to 15 clock pulses. But in this case, we can say in this case here n is 4 bit, but it count only 4 states. So the big and basic difference of number of state in the normal counter to the ring counter or Johnson counter. In the ring counter, it is count n state. N is number of bits, and also the number of flip-flops are 4. This is the big difference, students. So please be understand this basic difference and calculate the each state frequency by the formula is frequency, that is the total frequency, divided by n. N is number of states. This type of question is asked as well as in the RTO exam and the GATE examination. Thank you.